Mm. In the last class, we were talking about molar conductance. So can you tell me what is molar conductance if you have revised anything? And before starting the class, I would request you to please turn on
Sir,
your.
one more of uh, sir, like at STP at 1 mole, then it is
Uh,
called molar conductance.
no, like, are you using what term? STP? You were
Also,
using
like
STP
one
term?
mole of cube.
Basically, see, do you have the notes with you?
Sir,
And please turn on your webcam as well. Turn on your webcam and please go through the notes and tell me what is written over there.
sir, conductance of all ions by 1 mole of an electrolyte when
In a
dissolved
second.
to a certain volume.
Right. So
Yes,
similarly,
sir.
let us talk about equivalent conductance. So conductance of an electrolyte obtained by dissolving 1 gram equivalent of it in certain volume again. So if you are taking 1 gram equivalent rather than your moles, then you will call it equivalent conductance. And the formula is going to be, you just have to replace your molarity with normality, right?
Yes,
For
sir.
equivalent. Now, I gave you a question in the last class, this one, why conductivity decreases upon dilution, but molar conductivity increases upon dilution.
Sir, because it depends on the number of ions,
Which word?
conductivity, and
Then
molar
why more?
conductance does not depend.
Hmm. No, this is not an answer that I was expecting. So let me do one thing. You have an entire week, right? I need a very appropriate answer for this one. Key why conductivity decreases upon dilution, but molar conductance increases. Okay. You have to relate
Sir.
it in terms of volume, like what is happening actually. So this homework is again given to you. So you have to find the appropriate answer for this. Now let us talk about effect of dilution on molar conductance. So as we already see that it is observed that molar conductance increases upon dilution, right? What could be the reason? The reason, so I am not going to tell you the reason. You have to find it yourself. Okay. I will ask you in the next class. Note it somewhere. Okay. So when concentration approaches zero, that means dilution is approaching to infinity. The molar conductance is known as limiting molar conductance. When your solution is infinitely diluted or the concentration is reaching to zero, then at that point, the molar conductance, this lambda m will convert into limiting molar conductance and you have to introduce this not sign. Lambda not m. Is it clear when we will call limiting molar conductance? When the dilution is infinity, your solution is infinitely diluted. Okay, you have diluted it by anything like water and you have made the maximum content of water. Okay.
Sir.
Now, this is one equation, Debye-Huckel-Owen-Seger equation, which helps us to determine basically the upon dilution how many number of like how many ions are getting generated in your solution. Okay. So basically, you just have to simply see this equation and they might ask you which one is correct. So you have to tick this one. What is this? Molar conductance is equal to limiting molar conductance minus A, which is a constant, and your concentration under root. This equation is only applicable for strong electrolyte. So let us see what is happening basically. Suppose this is a graph, right? What is happening as you are moving from right to left, dilution is increasing. As the concentration is decreasing from left to right, you can say dilution is increasing or not. Can we say this or not? That if I am moving from right to left, the concentration that I am observing is decreasing. It is coming to 0.2 from 0.4. Basically, the concentration is decreasing from left to right. And simultaneously, what we can say that dilution is increasing. If concentration is decreasing, that the dilution will be increasing.
Yes, sir.
Now, what we observe, if you are taking a weak electrolyte and if you are taking a strong electrolyte, what is the trend of increase in molar conductance? Okay, if the concentration is decreasing, basically you are making your solution more diluted. What you observe? That the strong electrolyte, you will observe a very slight increase in molar conductance. But on the other hand, your weak electrolyte shows a very drastic increase in molar conductance. What could be the reason? Your strong electrolyte, upon dilution, the molar conductivity is increasing, but that is not that significant. But when you are doing the dilution in weak electrolyte, the molar conductance is increasing, and that too very drastically. What could be the reason of it? What? How? Tell me. Go ahead.
Sir, because strong electrolyte is like fully dissociated and weak electrolyte is like less dissociated.
Very good. Upon dilution, what you observe that the number of ions are getting increased in your solution for weak electrolyte because initially the number of weak electrolyte is not completely dissociated. If you are diluting it, the degree of dissociation is increasing. So after dilution, you are getting more number of ions. On the other hand, in your strong electrolyte, the ions were already completely dissociated. So upon dilution, what is happening? You are just increasing their mobility by providing more space. Is it making sense?
Yes, sir.
How about? Hmm. So here we have the reason. In case of strong electrolyte, for example, KCl and NaCl, the number of ions remains same, but the inter-ionic attraction decreases, resulting in gradual increase in molar conductance. After dilution, even before dilution, the moment you dropped your strong electrolyte into the solution, it get completely dissociated. When you are doing the dilution, the number of ions are still same, but what you are observing, the distance or the basically the area for those ions is increasing, so they are more mobile mobile, right? They can move more freely. The interionic interaction is basically decreasing, so this is the reason we are observing a slight increase in molar conductance. But okay, I have written something else because strong electrolyte KCl में पहले ही complete dissociation होती है, यहाँ पे सिर्फ mobility बढ़ती है, ठीक है? In case of weak electrolyte, the number of ions increases on dilution. The number of ions are itself getting increased. Due to the increase in degree of dissociation, more ions are getting dissociated, resulting in drastic increase in the molar conductance. Because weak electrolyte, for example, acetic acid, में degree of dissociation क्या रहता है? हाँ, डिग्री ऑफ डिसोसिएशन 0 to 1 होता है, यानी कि 0% से लेकर 100% के बीच में होता है, ठीक है? जो डाइल्यूशन में और डीओडी होके नंबर ऑफ आयंस बढ़ जाते हैं, सिंपल बोले तो पहले पूरी तरह डिसोसिएट नहीं होते, डाइल्यूशन पर हो जाते हैं तेजी में, राइट? यू कैन से दैट initially when you are just transferring your weak electrolyte, they are not getting completely dissociated. The margin could be 0 to like it could be 10% dissociated, 20% dissociated. The moment you are transferring your solvent, basically you are making it more dilute, then the percentage, the degree of dissociation is increasing. That is leading to the number of ions that are increased in your solution now. Initially, there were 10 ions which were conducting electricity. Now there are more. So if the ions are increasing, the molar conductivity will increase. Is it making sense? Is it clear?
Yes, sir.
This question will appear in your exam. So you should be clear with this, what is happening with strong and weak electrolyte. Okay. This chapter is going to be completed like 1 or 2 pages are left. And what I am going to do is I will share you the like the more detailed PDF as well. Okay, so if in this PDF you are having any trouble with any point, like you are not able to understand it clearly, so I would request you to get the reference of the other PDF because in that PDF you will find things written in a bit more detail, right? And if you are not able to understand from that PDF as well, then you have to ask me. Okay. but
Yes, sir.
don't let yourself like कोई भी doubt नहीं रहना चाहिए. So the last topic of this chapter is Kohlrausch law for independent migration of ions. What is this? So what we can do is I will give you 2 or 1 minute. Please read this and tell me what you are getting from it. What can you interpret from this definition?
And sir,
Okay. So what can you tell me after reading this? What is happening? What is Kohlrausch law? What have you understood?
sir, if you want to find the conductivity of an electrolyte, like we can add its individual ions,
But
like
at
the
what
sum of it.
condition? What condition? Like Euler's law is applicable only at what condition? At infinite
Infinite
dimension.
dilution.
You are right. That's the entire law. Okay. So what is Euler's law? At infinite dilution, when the dissociation of electrolyte is complete. So you have to wait till your ions are completely dissociated. Your electrolyte is completely dissociated. The moment your electrolyte is completely dissociated into their ions, then what you can do? The limiting molar conductivity of the electrolyte. What is limiting molar conductivity of the electrolyte? Basically the molar conductivity at infinite dilution can be represented by sum of individual contribution by the anion and cation of the electrolyte. For example, if you have to calculate the limiting, this thing is indicating that we are talking about infinite dilution. This dot is representing the infinite dilution of NaCl is simply the limiting molar conductance of your cation and anion. That's it. Okay. The general equation is limiting molar conductance is going to be your cation and anion. For example, if you are talking about BaCl2, then what you are going to observe? Ba 2 positive and your Cl negative, and how many Cl do you have? 2. So this is how you are going to use your Kohlrausch law. Simple as that. Any difficulty from this one?
No, sir.
Now, let us talk about degree of dissociation and dissociation constant. And we have this Faraday law. I don't know whether it is still in your syllabus or not, but I will teach it. Degree of dissociation. We have talked about this term in the solution chapter. So do you remember anything about this? What is degree of dissociation?
The degree of like the like how much it breaks down, how much it
Okay.
dissolves.
Good. So for a strong electrolyte, what is your degree of dissociation? What is this one signifying?
100% dissociation.
Good, good, good. But for weak electrolyte, like your acetic acid, the degree of dissociation alpha varies from 0 to 1. It could be 0%, 10%, 2%, 50%, anything between 0 to 1. The increase in the increase in molar conductivity with dilution is due to increase in degree of dissociation and consecutively the number of ions in total volume of solution that contains 1 mole of electrolyte. So this specific third point is only applicable for what? Weak electrolyte. Because in weak electrolyte, you are observing the increase in the number of ions because initially the electrolyte was not completely dissociated. So the third term is only applicable for what? Weak electrolyte. So in weak electrolyte, upon dilution, what you are observing? Upon dilution, the degree of dissociation increases. Your electrolyte is getting more dissociated. Initially, if it was 10%, now it is 20% or 50%. The ions are basically increasing. If the ions are increasing, then there are more candidates to carry the charge. If there are more ions basically that are carrying charge, then your ultimately the molar conductivity is going to increase. That is the reason. Okay.
Yes, sir.
The fourth one, which is a formula. The ratio of your molar conductance and your limiting molar conductance is also known as your degree of dissociation. If you know your molar conductance and if you know your limiting molar conductance and if you are dividing them both, then you can also find what? Your degree of dissociation with the help of this formula. Okay.
Yes, sir.
Now dissociation constant. Okay, just give me a second. Suppose if you have a weak electrolyte, if a weak electrolyte is going to be in equilibrium with their ions basically because it is not getting completely dissociated. So what you are going to observe that this acetic acid will dissociate into a this ion, an ion and this cation. Okay. Initially when the reaction is not started, it is going to be in 100% like C concentration, and if the reaction is not started, then you won't observe any cation or anion. Okay. The only thing that you are going to get is your acetic acid. Suppose आपने कुछ सामान ले लिया, ठीक है, आपने उसमें रिएक्शन चालू ही नहीं करी, तो आपका 100% वही रहेगा ना एसिटिक एसिड ही, जब रिएक्शन ही चालू नहीं हुई है कि नहीं?
Sir.
सी का सी एंड वहां पे राइट साइड 0 0। बट आपने रिएक्शन चलने दी कुछ टाइम तक, आफ्टर टाइम टी, आफ्टर कुछ टाइम, what you will observe that your acetic acid is going to dissociate by some C alpha. Initially, if it was 100, some amount is getting dissociated from here, and we are considering it what? C alpha. And the amount which is getting dissociated from the reactant side is going to appear on the product side. So if we are observing dissociation of C alpha on the reactant side, then in the product side we will observe the formation of C alpha, because जो वहां से टूट के जा रहा है वो प्रोडक्ट की साइड जा रहा है ना. Is it
Sir.
making sense?
Yes, sir.
Now, what is your dissociation constant? It is represented by K, and it is nothing but your product key concentration divided by reactant key concentration. So in product, what do you have? C alpha, C alpha. In your reactant, you have C minus C alpha. So after solving this, you will get this formula, which is called dissociation constant formula. Okay.
Yes, sir.
So what things we have? Let's check this. ये छोटा सा फॉर्मूला है, क्वेश्चन है बेसिकली इन योर एनसीईआरटी इन टेक्स्ट क्वेश्चन नंबर 4. डू यू हैव योर एनसीईआरटी विद यू राइट नाउ?
Yes, sir. One second.
हाँ प्लीज. Thank you. Now we are going to do some questions.
Yes, sir.
See the question number 4. Tell me what is given and what they are asking.
Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10.
pH is given and what you have to calculate from it?
Potential of hydrogen electrode.
Potential. So you have to find E cell basically, right? E cell is potential or not?
Yes, sir.
So we know the formula from our chemical equilibrium chapter from your 11th class, that the pH is nothing but log minus log H positive. Okay. This is your pH
Yes,
ka
sir.
formula.
Yes, sir.
And pH is already given, which is 10. Right?
Yes.
Now, what we have to do, we have to use the logarithm to get our H positive. So in chemistry, the base is usually 10. So if I'm considering this thing, what I'm going to do is that this log 10 is going to convert into what? It will go on the right hand side and it will look like this power. Let me show you how what I'm basically trying to tell. Okay, so let me just and of how we used to get conductors. See, this is log 10. Okay, if I'm sending my log 10 to the right hand side, how it will change? How it will change? This will convert into basically 10, and this will go into the power. Suppose if you see this thing, here we have log 10,000, and if I'm sending my log 10 to the right hand side, it will go like this, 10 to the power 3.
Sir, so it works for like other numbers as well, like log 100.
Like in chemistry in this chapter, the usual term that you are going to use is log 10. So it is easier here.
Yes, sir.
Basically, if you are sending your log, it converts into exponential. It will look like this, e exponential. Okay.
Yes, sir.
Ideally, if you don't have any value like log 10 we are considering here, if you don't have that, you have to consider it like this, h positive exponential 10. And then you have to solve for the exponential. But for chemistry, for this specific chapter, the things are easier. You have to consider it as log 10. Okay.
Sir. Yes,
So
sir.
for your H positive, the concentration that you are getting is 10 to the power minus 10. Simple as that. And I've explained the data here as well. This is your log B. Okay. So
Sir.
how it is going to change? This log B on the right hand side, it will go like this. B will be in the power ke niche, and your Y will become the power, and it will go to the X is equal to X. So B base usually 10. ठीक है. X क्या है? The number we take to the log of. Y the number we take the power we need to raise to the base to the. ठीक है. सिंपल सा अगर बोलें तो क्या होता है? लॉग उधर जाके पावर मतलब जो नंबर है वो चला जाता है नीचे, और पावर ये जो एक्सैक्ट वैल्यू होती है पावर में चली जाती है. ऐसे करके याद रख लो अभी के लिए, तो सिंपल तरीका है. ठीक. Now
Sir.
we know we are talking about hydrogen, and what is happening? Reduction or not?
Yes, sir. Reduction.
So H पॉजिटिव एक इलेक्ट्रॉन लेके किसमें बन जाएगा? इसके अंदर. तो अब अगर आपको क्या निकालना है? आपको निकालना है पोटेंशियल विच इज बेसिकली ई सेल. तो वी हैव नर्स इक्वेशन और नॉट? वी हैव नर्स इक्वेशन.
Sir.
नर्स इक्वेशन क्या बोलता है? कि आपका ई सेल होगा इज इक्वल टू ई नॉट सेल माइनस 0.0591 डिवाइड बाय एन लॉग टू दी पावर सॉरी लॉग थीटा. एंड दिस थीटा इज व्हाट? रिएक्शन कोएफिशिएंट. एंड थीटा बताता क्या है? प्रोडक्ट की कंसंट्रेशन डिवाइड बाय रिएक्टेंट की कंसंट्रेशन. And what I told you in the last class that we only consider what? The concentration of
Aqueous.
aqueous. ठीक है. So यहाँ पे आपको क्या करना है? बेसिकली जो आपका हाइड्रोजन इलेक्ट्रॉन एस एच होता है, उसका मैंने बताया था लास्ट क्लास में कि उसका स्टैंडर्ड इलेक्ट्रोड पोटेंशियल कितना होता है? 0, क्योंकि रेफरेंस इलेक्ट्रोड
Sir.
है ना. उसके रेफरेंस से तो निकालते हैं. आपको पता है कितने इलेक्ट्रॉन्स का लेन देन हो रहा है यहाँ पे? एक का एन की वैल्यू एक आ गई. देन यू विल पुट द वैल्यू सिंपली एंड यू विल गेट योर आंसर. The main thing which students find a bit different or they are not able to understand is this part. Ki how we are converting this log wala funda. Because this part is from the chemical equilibrium chapter. And the thing is very simple. You just have to know some knowledge of your logarithm. Ki how we are doing this. Okay, so do one thing, see this question and let me know if you are having any doubt here. From the starting and the end, and read the question like simultaneously. Like you have to understand the question itself. The only way you will be able to answer the solution with. Now we are going to do so many questions, so we can pack this chapter. The last topic is for Radha, I guess.
Done, sir.
Okay, just give me a second. Okay, good. Do you have the latest version of your NCRT? Like this session's book, new
No,
book?
sir. No, sir.
Okay, okay. I'm not sure whether the Faraday law is still in your syllabus or not. Just give me a second, let me check this. In electrochemistry, what do we have? Redox, EMF, standard electrode, application to chemical solution using which one is conductance in electrolyte solution, present over conducting variation of conductivity in temperature, Kohlrausch law, dry cell, electrolytic cell, pelvic cell, electrometer. हम्म फराडे लॉ तो सिलेबस में नहीं है, बट फिर भी हम पढ़ लेते हैं, क्या पता टपक जाए क्वेश्चन। ठीक। व्हाट
Sir,
इज फराडेज लॉ? फराडे के दो लॉ है बेसिकली। फर्स्ट लॉ इज व्हाट? द अमाउंट ऑफ गिवन प्रोडक्ट लिबरेटेड एट एन इलेक्ट्रोड ड्यूरिंग इलेक्ट्रोलिसिस इज डायरेक्टली प्रोपोर्शनल टू द क्वांटिटी ऑफ इलेक्ट्रिसिटी व्हिच passes electrolyte. Simple. आप कितना the amount of product that you are liberating, suppose you have a electrode and the more amount of electricity will pass, more amount of the electrode will get dissociated, the amount will be liberated from the your electrode if you are applying more electricity. So please read this formula. Oh, sorry, the definition basically what it is suggesting or saying that the amount of given product liberated at any electrode during electrolysis is directly proportional to the quantity of electricity which passes through the electrode solution. So कितना मास लिबरेट होगा वो किस पे डिपेंड करेगा? सारा का सारा चार्ज पे। And what is the charge? Like how can you expand this charge? Charge is nothing but IT, because your current is what? Current is charge per unit area. And if you have to replace your charge, you can basically put I into T, current into time. So uh, more mass will be liberated if you are providing more current and more for more period of time, IT. And if you have to remove this proportionality sign, you will introduce Z, and this Z is electrochemical equivalent, basically electrochemical equivalent, and I is current, ampere, and time is in seconds basically. Okay, this Z is what? Z is electrochemical equivalent, and you can expand it even further by putting E divided by 96500. This formula you will get. And what is this E? Uh, this E is basically your equivalent mass. And what is equivalent mass? Basically, your atomic mass divided by n factor. And what is n factor? We talked about this in solution while we were talking about normality. So this is your formula. And how much is 1 Faraday? I told you in the last class what 1 Faraday basically means. Charge on 1 mole of electron. So you are going to get this value 96500 coulomb. What
sir,
is second law? Second law says that when same amount of electricity you are passing through different electrolyte, then equal amount of equivalent will be deposited or produced in a cell. अगर आप same electricity different different cells में दे रहे हो, different different electrodes को, तो same amount of deposit भी होगा, same amount liberate भी होगा. That's it. ठीक.
sir.
Cell A, cell B, cell C. If you are providing same amount of electricity, then same amount or same equivalent of mass will be liberated or dissociated. Charge on 1 mole of electron is this. Ag 1 mole of Ag requires 1 Faraday charge. 1 mole of Cu require 2 Faraday charge. 0.1 mole of 1 Faraday deposit 1 equivalent of any species. This is your difference between Daniel. This is just the definition you can see from here. And that's it for the chapter. Let me do one thing. See, I'm going to share this PDF as well. This is the थोड़ा लेंथी वाला PDF जिसमें चीजें थोड़ा ज्यादा एक्सप्लेन है. And यहाँ पे you will find some question associated with your topics. For example. हाँ थोड़ा वो रह गया थ्योरी वही बनाने को. There are some questions as well that you can take reference of. Hmm. So I have to have few things. I guess. Yes. Hmm. See, if you are talking about Kohlrausch law, if you are talking about Kohlrausch law and you are taking equivalent conductance, then how you are going to proceed? The thing is same. Your equivalent conductance, your basically your limiting equivalent conductance is going to be the sum of cation and anion. But what is different here? If you are using this equivalent term, then equivalent में number of ions से multiply नहीं करते. What do you mean by this? See here, ideally you should have used 3 here, right? Because 3 chlorines are present. So for equivalent, what you will avoid? You will avoid to multiply it by the number of ions basically. If you are talking about molar, then you will use the normal agenda. Like if you are having 3Cl here, then you will use the 3 term. But if you are using equivalent, then you have to avoid the 3. That's the difference only difference.
Sir.
Equivalent में number of ions से multiply नहीं करते, molar में करते हैं. And we have this new formula which is rating equivalent and your molar. What is this? Your limiting equivalent conductance is equal to limiting molar conductance divided by charge. Okay, how you are going to calculate the charge? Charge will be given as a oxidation state. That's it. Okay,
Yes, sir.
so there are some miscellaneous topics as well that we need to take upon. I will copy paste it from the. So, so this is some theoretical portion that we have to directly read. What are batteries? What are fuel cells? Okay. What is corrosion? So let us go through this as well. So what are batteries basically? So any battery uh, or cell that we use as a source of electrical energy is basically a galvanic cell. What are batteries? A galvanic cell. What is a galvanic cell? Can you tell me what is galvanic cell?
Uh, Sir, like it converts chemical energy to electrical energy.
So your batteries are what? Something which is converting your chemical energy into electrical energy. So it is a galvanic cell or galvanic cell example basically.
Yes, sir.
Of the redox reaction is converted. However, for a battery to be practical use, it should be reasonably light, compact, and its voltage should not vary appreciably during its use. There are mainly two types of battery. So we have two types of battery. What is a battery? A galvanic cell. Okay, simple as that. And how can you make a battery a better battery? To make it lighter, so that you can carry it easily, and its voltage should be stable, so that it can supply a stable voltage, so it won't harm your appliances. You might have heard if your like voltage is not constant, it is like fluctuating a lot, then it might harm your devices or not. So what is a good battery? That is not giving fluctuating voltage. That's the use of stabilizers. We use stabilizer in our ACs now. Sometimes like we have separate stabilizer for the voltage so that our AC won't get like no primary battery. What is primary battery? In the primary battery, the reaction occurred only once, and after use, after use over a period of time battery becomes dead or cannot be reused. So वो वाला बैटरी है जो एक ही बार यूज करते हैं ना, फिर फेंकना पड़ जाता है, ठीक है। प्राइमरी बैटरी इज व्हाट दैट इज ओनली यूजेबल फॉर ओनली one time. What is an what are what can you tell me some example of primary battery?
Sir, batteries like in the remote.
जो सेल वाला जो बैटरी होता है, ड्यूरा सेल का, right?
Sir,
The most familiar example of this type is the dry cell, जिसको हम क्या बोलते हैं, Leclanche cell after its discovery, ठीक है, which is used commonly in transistors and clocks. The cell consists of zinc container that also act as anode, and the cathode is a carbon graphite rod surrounded by powdered magnesium dioxide. See, if you see this diagram or figure, you can see that this is how a primary cell looks like. It has its cathodic and anodic part as well. This carbon rod is cathode, and this zinc cup is your anode. The reactions are as follows. The zinc is basically getting oxidized, because at anode you will observe always oxidation, and at cathode you will observe reduction. In the reaction at cathode, the same, it is basically explaining what is happening. So we know how the oxidation state converts from one state to another. Okay, 2.9 is Mercury example again. Example of your primary cell. A primary cell is what? Which is only usable only one time, right? We
yes.
cannot recharge it. So what is secondary battery? Something we can recharge. Secondary battery or secondary cell after use can be recharged by passing current through it in the opposite direction so that it can be used again. A good secondary cell can undergo a large number of discharge and charging cycles. The most important secondary cell is the lead storage battery. If you see this, this is your lead storage battery, and it is an example of your secondary cell, which is commonly used in your automobiles or inverters. It consists of lead anode and grid lead packed with this, ठीक है। एनोड पे ये रिएक्शन होती है, इतना ज्यादा पूछेंगे नहीं यहाँ से, ठीक है। On charging the
Yes,
battery
sir.
and reaction is reversed. So this is basically a theory stuff. You can read it from this. I will add it in your notes. Okay, so what is the difference between primary and secondary battery? If somebody asks you what, how can you explain it in like 2 minutes?
Uh, cannot charge primary battery.
But you can
Like
recharge a
we
secondary battery.
should, yeah, we can only use it one time. And for secondary battery, we can use it by charging.
The next thing is your fuel cell. What are fuel cells? Production of electricity by thermal plant is not very efficient method and is a major source of pollution. So basically that the thermal plant that we are using, it can produce some pollution like what we call that global warming is a reason of these types of thermal plants, right? Because they are producing so much heat. In such plants, the chemical energy, heat of combustion of fossil fuels like coal, gas, or oil is first used for converting water into high pressure steam. This is then used to turn turbine to produce electricity. We know that a galvanic cell directly converts chemical energy into electrical and is highly efficient. It is now possible to make such cells in which reactants are fed continuously to electrodes and products are removed continuously from the electrolyte component. Galvanic cell that are designed to convert the energy combustion of fuels like hydrogen, etc. One of the most important. See, here they have written it like a bit more. Let me give you a very simple definition of fossil fuel cells. Just give me a second. So basically what is happening here, you are using the fuel which is hydrogen, like basically gases, natural gases or methanol, which are not very like they are environment friendly. Usually like they are supplied in the form of air. So what is happening? You are using these type of gases and they are basically using your chemical energy and converting into the electrical energy. I will give you a better definition of this and I will add it into the notes and you can read it from here. It is like theory basically, okay? What are fuel cells? They are better version of your like basically not causing global warming. They are like what do you say? थोड़ा सा better है environmentally fuel cells. क्योंकि यहाँ पे जो हम
Yes,
यूज
sir.
कर रहे हैं वो उतने ज्यादा हार्मफुल नहीं है मतलब हीट जनरेट नहीं करते. व्हाट इज करोजन? यू माइट
Sir,
हैव हर्ड इट इन योर
yes, sir. Due to oxidation.
oxidation. So this is your corrosion basically. They won't be asking you much from here, but I would still suggest you to go through the thing. Like you can just give it a read. Take in like common knowledge, like the way we did for primary and secondary cell. Na, you should have a basic idea what is happening. Corrosion is simple, oxidation of your iron, right?
Yes, sir.
So this is your corrosion. I will add these slides in your notes and I will share. So your chapter is complete. Now let us do some questions. So that, one more thing. We only are like three chapters are left, and for the syllabus, right? We only need
Yes,
to
sir.
cover chemical kinetics, D and F block, and what other chapter? I think after this only two chapters will be left. Or am I missing something?
Sir, we don't have surface chemistry here.
No, no, no.
Surface.
We don't have surface chemistry in this syllabus.
Sir, only two. Yeah.
Okay, so what I am thinking is rather than moving forward, we would revise. Like if you are having any specific chapter that you think you need revision, right? That you think you are not having a like the idea, like you are not able to understand the chapter entirely. So we will do that chapter. We are going to start the revision from here because only two chapters are left and we can cover it in like 1 or 2 weeks. That won't take any time. So what should be like what what we should proceed with this? Like we should revise because revision is important. So I would request you to tell me a chapter which you want for your revision. Which chapter we should start for revision after this one? Which chapter is not clear?
Uh, Sir, for revision, we can start from like the first chapter.
From the first chapter itself. Okay,
Yes, sir. Like,
solution.
yeah, because no chapter like in particular, so like we can just revise from the start.
Okay, we will do that. But the thing is, I would again suggest you if you are if you want to understand organic chemistry now, then you should daily revise it. Like take some topics, specific topics, and revise it. Okay. Otherwise,
Yes, sir.
at the time of your exams, now you will find organic chemistry a bit more complicated. We will start the solution. I don't have a problem with that. Now,
Okay,
can
sir.
you see this question? Example number 2.1. They are basically asking what? They have given you this reaction and they want you to calculate its E cell. And what they have given? The E naught cell. So what you know? You know the formula. This is Nernst equation. You can simply put the values and you will get your answer. Is there any problem with this one?
Sir.
And what other thing they have asked? They have asked to show it in a standard condition. Like you know, na, we write the anode part on the left hand side, then we add salt bridge, and then we write cathode. This is the
Yes,
general
sir.
way of representing a cell. This question. Now they have introduced this term equilibrium, right? Equilibrium constant. What I told you. How does Nernst equation changes if we are using this equilibrium term?
Uh, Q gets changed to K.
Right, 0 point, which changes to what?
Log Q changes to log P.
Log K equilibrium.
Sir,
What else?
okay.
This E cell becomes zero because at equilibrium, we are not observing any redox reaction. So this thing will
Sir,
become zero. And if you are sending this thing on the left hand side, then it will be in positive, and you will have your formula like this. Or not,
sir,
E not cell. So you have this reaction and you have calculate the equilibrium constant of the reaction. You have to calculate basically K equilibrium. And you know the formula. Formula is going to be like this. Why we are using 2? Because the change in electron is 2. And then you have to solve it for Kc and you will get your answer. Okay.
sir.
Now this next question थोड़ा सा important है. थोड़ा देखो इसको क्या हो रहा है मुझे बताओ जरा. आंसर भी लिखा हुआ है by the way. But what is question asking? First tell me that. Okay, tell me what the question is asking.
The question is asking to find the Gibbs free energy. So we use
Yes,
the
free energy.
formula. Yes,
Can you use this formula, right? Simple. F is constant, which is having a specific value, which is basically 96500. You can round it off to 9596500 to simplify your calculation. Okay, what else? This n can be calculated by you basically have to do the half like reduction half cell, oxidation half cell, and this is the net reaction.
sir.
Okay, now we did this question, I guess. So solve for me, you have to solve this question. Let me see whether you are able to solve this or not. Question number 5, solve it in your copy. Tell me the answer. A simple question from nurse equation. Do it in your copy and don't take any help from the internet. Okay. I want to see whether you are able to solve it or not. You can use the calculator by the way.
Sir, the value of Faraday was 9 uh, 94500.
Uh,
Uh,
Ferrari, the constant you
yes,
can
sir,
use
the constant
96500.
9630.
Let me know once you're done.
Sir, I got 4.7 into 10 to the power 12.
Hmm. I think you have done some mistake. Let me see. Hmm. See, what you have to do, you have to use the simplest formula for your Nernst equation, which is minus 0.0591 divided by n log theta, right?
Yes, sir.
In the question, what is the reaction basically? Solid 2Ag positive 0.02, right? It is giving aqueous, which is 0.160 plus 2Ag solid. And they have given E naught cell, which is 1.05. So what you had to simply do is E cell is equal to 1.05, 0.0591 divided by 2. Do I need to explain why I'm writing 2 here?
No, sir.
Okay, good. Log product की concentration. In side product you have this aqueous Ni plus 2 divided by Ag positive, but this stoichiometry is going to get converted into the power. This is 0.160 divided by 0.002 का होल स्क्वायर. यहाँ तक ऐसे ही आया, कुछ और आया था?
Sir,
Now what we can do, इसको सॉल्व करना है, ठीक।
Sir, but I did not 0.059156. That's all.
क्या
Sir,
बोल?
I did not use 0.0591 by 2.
ओके,
That's why I
इससे
got it
पहले
wrong.
वाला क्वेश्चन यूज करा, you have used a more generalized formula, you haven't
Yes, sir.
considered the standardized part, right?
Yes, sir.
So I told you na, if in question they are giving you a temperature which is not 298 Kelvin, they are specifying that the temperature is either 350, 150, apart from 298, or either they are not giving the temperature as well. So you have to use this formula itself. You don't have to go there. That formula is where the things are not standardized. But luckily, in your exam, most of the question are going to be considered in a standardized condition, because in most questions they are not going to give you the temperature. If they are not mentioning the temperature, you have to consider it as a room temperature automatically.
Sir.
Okay.
Yes,
Now
sir.
let us do the calculation. How we can do the calculation ना? 3 राइट साइड गया तो क्या आएगा, -3 और नॉट
Yes, sir.
चल रहा है, ठीक। इसको हम करते हैं सॉल्व। सो 4 × 10⁻⁻6 हो जाएगा।
Yes, sir.
अब कैन वी सब्सट्रैक्ट दिस थिंग, और व्हाट वी कैन डू, यहाँ से ऐसे करा इसको मैंने, यहाँ 10⁻³ आएगा तो प्लस कर दिया, सिंपल सी बात। कितने पे आ जाएगा, 40 पे, राइट? 10⁻⁻3। Are you getting what I'm doing? Basically, the maths, how I am making things simplified, like how you can simplify things for, like you can do the calculation easily. So यहाँ
Yes,
पे क्या
sir.
होगा, ये ऊपर आ जाएगा, या 10⁻³ रहने दिया मैंने, ठीक। तो ऊपर भी दूंगा तो 10⁻² हो जाएगा, तो बजे करना चाहिए नहीं। कर लेते हैं, ठीक। ऐसे लिख सकता हूँ
Sir.
क्या,
Yes, sir.
और इसको ऐसे भी लिख सकता हूँ, 10⁻⁴, राइट?
Sir.
Now what I'm going to do is 10.05 minus 0.0591 divided by 2 log, you know what is log a into b? Log a into b is what? Log a plus log
Log
b.
B.
This is a property. Thick.
Yes, sir.
So what I'm going to do is I'm going to use this property here. 4 plus log 0 2 3 4, ठीक है। What is log 4?
Uh,
We can use a like phone as well for this one. No? You will learn it if you are practicing the questions now. You will automatically learn it. You don't have to worry about it. 0.6, ठीक है। log 10 होता है 0, log 10 0 होता है, log 1 0 होता है, बताओ।
log 1 0.
ठीक, log 10 क्या होगा,
Log 1.
100 कितना होगा, तो यहाँ पे क्या आ जाएगा बताओ, व्हाट यू विल गेट हियर। 4 log 1000 is 3, log 10,000 is 4। इसको सॉल्व करोगे तो क्या आ जाएगा आपके पास, पोटेंशियल 0.91 वोल्टेज, ठीक है। एक बार देखो, इसको कुछ प्रॉब्लम है तो यू कैन आस्क। कोई is there any point you are not able to understand any mathematical term or anything?
No, sir.
Okay, so if you are able to understand this, then do the next question on your own. Let us see whether you are now able to do this one or not. If you are able to do this question, then you can consider yourself like you have understood the entire thing about Nernst equation, because it is using Gibbs energy and equilibrium. Like it has merged all the concepts related to Nernst equation. Try to do it. See, here you can see the temperature na 298 Kelvin. It is standardized state. So you have to use the letter formula 0.0591 wala. One more thing that you should see. You have to write the reduction half cell and oxidation half cell, because here the number of electrons are not that simple, because if you are seeing this, it is gaining one electron, and here it is simple again. To be safe, always try to write the reduction half cell and oxidation half cell, so you can know what is actually happening inside. This is a net chemical reaction. Okay, what I can do for you is I can help you with the reaction. Just give me a second. Hmm. Fe क्या कर रहा है? Fe is doing reduction or oxidation? Tell me. Either Fe is doing reduction.
Reduction.
Good. So it is
Reduction half.
one electron it is gaining and converting into two positive. Okay.
Yes, sir.
यहाँ तक कुछ दिक्कत? Now ये क्या कर रहा है? ऑक्सीडेशन और रिडक्शन?
Uh, Oxidation.
ऑक्सीडेशन हाफ से इसके पास एक एक्स्ट्रा इलेक्ट्रॉन था, उसने वो दे के न्यूट्रल चला गया, तो इट इज लूजिंग इलेक्ट्रॉन. आई नेगेटिव लॉस्ट वन इलेक्ट्रॉन एंड कन्वर्ट itself into like this, right?
Sir.
Uh, no. So in this equation, what do we have? We have 2, so we have multiplied this entire thing by 2. Okay, then 2 से मल्टीप्लाई करा तो यहाँ सब जगह 2 आ जाएगा. 2 2 2, दो इलेक्ट्रॉन से दो इलेक्ट्रॉन चला गया, तो क्या बचा यहाँ पे हमारे पास? सिर्फ और सिर्फ 2 Fe+3. ठीक. और यहाँ पे पहले सिर्फ आई था, और ये 2 से मल्टीप्लाई करा तो ये आई कहाँ चला गया? बेसिकली ऐसे करके आ जाएगा, यहाँ से तो ऐसे आ जाएगा. +2 I नेगेटिव गिव्स I2 + 2Fe+2. राइट. सो ये आपका नेट रिएक्शन है, कहाँ से आया? ऑक्सीडेशन एंड रिडक्शन ऑफ सेल से. तो आपको यहाँ पे क्या पता लग गया कि एन आपका क्या है? 2. So with the help of this data, now you will be able to solve. What you have to basically find? You have to find Gibbs free energy. For Gibbs free energy, what formula do you have? Tell me. For delta G, what
Uh,
formula do we have?
Minus and Fe.
Good. So apply that formula and tell me the answer. And then you have to find the equilibrium constant. For equilibrium constant, what formula do you have?
Uh, E cell into 0.0591
Mm-hmm.
by n log
Mm-hmm.
cube.
So apply that formula and tell me the answer. Is it making sense? Are you able to get the approach how you are going to deal with these kind of questions? What are the steps that you have to follow
Sir.
to solve it?
Sir, Gibbs free energy I got minus 45.5 kilojoule per mole.
Let me check. Minus
45.5.
45.5. Good, good, good. This is the correct answer. Kilojoule per mole. Good.
Yes, sir.
Calculate the rest part.
Sir, how should I solve log Q?
Uh, log
Like the
Q,
number
log
of
KC, you
moles.
mean?
Yes, sir. Log is.
So for that, now you have to take anti-log. Right? I will teach you the anti-log later. You can leave it till the point like this. You might be getting KC, something like that. Log KC is equal to some value, right? 7.983. And then you have to take the anti-log. I will teach you the anti-log later. Okay, so you can leave it till point.
Yes, sir.
So are you able to
Sir.
understand what is happening, right?
Yes,
Okay,
sir.
just give me a second. Okay, what I was saying. ठीक है ये वाला क्वेश्चन I have to teach you the anti-log. Basically, it is a table that you have to learn. Okay, so what else do we have? Um, and please take a screenshot of this slide because it is not included in your the PDF I'm going to share now. Take a screenshot of it.
Yes, sir.
Hmm. Okay, let us do some more questions. And in the next class, we will start the revision of the solution chapter. Hmm. This is a question from your the later part, the conductance part. So what it is saying basically, you have given what the resistance of a conductivity cell filled with this is concentration that you have given is this. The resistance is given, the conductor concentration is given if the resistance of the same cell when filled with 0.02 mole per liter KCl solution is this. Calculate the conductivity and molar conductivity. You have to find the kappa and lambda m. Okay, the conductivity of this is this. So how are you going to proceed? Let us see. What else? What other question do you have? What is that? Okay, see. There's a question here. So first of all, what is given? The resistance, which is 100 ohm. Okay. The conductivity cell filled with 0.1 moles per liter concentration is given. Okay. If the resistance of the same cell when filled with 0.02 concentration किसी solution is this. तो इसने क्या बोला पहले? इसने बोला कि अगर 100 रेजिस्टेंस है तो इतनी कंसंट्रेशन है, अगर रेजिस्टेंस बढ़ा के 520 कर दी तो इतनी रेजिस्टेंस है, इतनी कंसंट्रेशन है. ठीक है. Calculate the conductivity. You have to find kappa and molar conductivity, which is lambda m of 0.02 mole KCl solution. The conductivity of 0.1 mole KCl solution is this. Okay, so what is the formula for your molar conductance? Molar conductance का formula क्या है? बताओ. K into 1000 divided by M, right?
Yes,
Is
sir.
it correct or wrong? I may be wrong. You have to see the notes. Whether this formula is correct or not for centimeter inverse or meter inverse, like you have to tell me.
For centimeter inward.
It is for centimeter inverse, right? But in
Yes, sir.
question, what is the unit they are taking?
Meter inward.
So I have to write which formula?
Uh,
देख के बताओ क्या है? What is the formula if you are considering the entire thing in center, like the meter thing? What is written?
into 10 by M.
Into 1000. What? Not 10 by n. Something like this, I hope. For meters, Simon, meter square, mole, inverse. Okay,
Sir, K by 1000 M.
K by 1000. So we have to use this formula. So, what we can do is the concentration at which we have to find the molar conductivity, and conductivity is given 0.02. Okay,
Yes, sir.
at this concentration, you have to find the things. So what you are going to do basically, this is in liter inverse. You have to convert it into what? Meter cube, or you can do what? Centimeter में भी कर सकते हो यार. इसमें आंसर अच्छा नहीं दे रखा. इसको सिंपल तरीके से करते हैं. ये हमारे पास फॉर्मूला के कंडक्टिविटी. वी हैव टू फाइंड फर्स्ट कंडक्टिविटी. ठीक है, कंडक्टिविटी भी निकालनी है अपने को. हाउ कैन वी मेजर द कंडक्टिविटी? कंडक्टिविटी इज व्हाट? कंडक्टिविटी इज
Uh,
ऑफ रेसिस्टिविटी. ठीक है, तो हम क्या लिखेंगे यहाँ पे? कंडक्टिविटी इज 1/रो
K by
ए
L.
बाय एल.
K
ठीक.
by L. Yes, sir.
Right, so what else you can do? I told you one more thing, that this is what? Nothing but cell constant G by rho. We can do this.
Yes, sir.
So if you have to measure G, which is your cell constant, what you are going to do? J is kappa into rho. ठीक है, अगर आपके पास सेल कांस्टेंट आ जाएगा जो कि यहाँ पे दे रखा है, दिस इज सेल कांस्टेंट, इट इज गोइंग टू बी इक्वल टू व्हाट? ओके, व्हाट इट इज. रेसिस्टिविटी इज गिवन 100. योर kappa for any specific solution is this. द कंडक्टिविटी दे रखी है ना, कंडक्टिविटी एरिया हमारे पास. तो कंडक्टिविटी और हमारी रेजिस्टिविटी से हम क्या निकाल लेंगे? जी. सेल कांस्टेंट फिक्स होता है सबके लिए. तो एक बार इफ यू आर एबल टू कैलकुलेट द सेल कांस्टेंट, ठीक है, उसकी मदद से आप क्या निकाल लोगे? देन योर कप्पा विच इज दिस कंडक्टेंस. देन फॉर मोलर कंडक्टेंस यू हैव दिस फॉर्मूला. यहाँ पे आप करोगे क्या? 1000 से मल्टीप्लाई कर देना नीचे, एंड यू कैन कैलकुलेट दिस एज वेल. सो इसको ना मैं सही से लिख के भेज दूंगा. इसमें एनसीईआरटी में ना, इसमें सही से लिखा हुआ नहीं है, इसमें थोड़ा मिक्स कर रखा है, तो मैं इसको सही से करके भेज दूंगा सिंपल तरीके से. ठीक है, बट द
Yes, sir.
थिंग इज कि आपको मोलर कंडक्टिविटी एंड सिंपल कंडक्टिविटी निकालनी है. अल्टरनेटिव क्या दे रखी है इसमें? कप्पा यू कैन मेजर विद द हेल्प ऑफ दिस फॉर्मूला. ठीक है, एंड योर मोलर कंडक्टिविटी विद द हेल्प ऑफ दिस फॉर्मूला. ये भी ठीक है, ये वाला भी ठीक है. मैं इसको सही करके भेज दूंगा. ये वाली अप्रोच बेटर है, इसको फॉलो करना है अपने को. पहले वाली बेकार है. सी फॉर कप्पा, व्हाट फॉर्मूला डू वी हैव? कप्पा इज नथिंग बट योर सेल कांस्टेंट डिवाइडेड बाय योर रेजिस्टिविटी. सेल कांस्टेंट आप यहाँ से निकाल लोगे, उसको यहाँ पे लगा देना. ठीक है, मैं इसको करके भेज दूंगा बाद में. अगला क्वेश्चन देखते हैं. इसको देखो. The electrical resistance of column is 0.05. This is this. Diameter is this. Length is this. Calculated resistivity, conductivity and lambda m. ठीक है। डायमीटर कितना दे रखा है?
सेंटीमीटर।
रेडियस क्या आ जाएगा?
0.5 सेंटीमीटर।
लेंथ क्या है? 50 सेंटीमीटर। ठीक है।
सर।
और सेंटीमीटर को मीटर में करोगे तो आप ऐसे लिख सकते हो, राइट?
सर।
अब आपको अगर रेजिस्टेंस निकालनी है, अगर आपको रेजिस्टेंस निकालनी है, रेजिस्टिविटी निकालनी है, ठीक है, तो आपको फॉर्मूला कौन सा यूज करना है? ये वाला। इस फॉर्मूले में आपको क्या क्या पता होना चाहिए? आपको लेंथ पता होनी चाहिए। लेंथ तो आपको सिंपल गिवन है, राइट?
सर।
बट फॉर एरिया व्हाट यू हैव टू यूज द फॉर्मूला पाई आर स्क्वायर। ठीक है।
यस सर।
पाई आर स्क्वायर से आपका एरिया कितना आ जाएगा? इतना। आपको लेंथ पता है, एरिया पता है, रेजिस्टेंस भी गिवन है। रेजिस्टेंस कहाँ गिवन है? ये रही रेजिस्टेंस। ठीक है। आप क्या निकाल सकते हो? सिंपल रेजिस्टिविटी विच इज गोइंग टू बी दिस। कंडक्टिविटी क्या होती है? कंडक्टिविटी जस्ट अपोजिट ऑफ योर रेजिस्टिविटी। रेसिप्रोकल करो, ये आ गया। मोलर कंडक्टेंस क्या होती है? कप्पा इंटू 1000 डिवाइड बाई सी। सी क्या है हमारी? कंडक्ट मतलब बेसिकली कंसंट्रेशन, जो कि हमें गिवन है यहाँ पे। ये देखो, ये कंसंट्रेशन गिवन है, तो यू हैव टू जस्ट द वैल्यू एंड यू कैन गेट योर आंसर। ठीक है।
यस सर।
ये सेंटीमीटर इनवर्स में आप मीटर में भी कर सकते हो, बट आपको ध्यान क्या रखना है? फॉर्मूला डिफरेंस इस्तेमाल करना पड़ेगा, यूनिट्स कन्वर्जन करना पड़ेगा। बोथ द
सर।
आंसर्स आर करेक्ट। ठीक है। तो एक बारी बाकी क्वेश्चंस यू शुड ट्राई ऑन योर ओन। इफ यू आर हैविंग एनी लाइक कुछ भी दिक्कत आ रही है किसी भी पॉइंट पे, यू कैन आस्क मी इन द नेक्स्ट क्लास। And in the next class, I will take your doubts first, and you have a homework. I told you now, like why the conductivity increases for kappa and decreases for dilution wala. That question and doubts from this chapter I will take first, then I will continue with the solution chapter revision. Okay. And I am
यस सर।
expecting so many doubts from this chapter, so you have to go through the NCRT questions. I am expecting questions in the next class. Okay. So please do some questions on your own. Is it clear?
सर।
Okay. So that's it for today's class, and we will meet on the next Saturday. Until then, revise and take care. Bye.
थैंक यू सर।